Okay, everybody, welcome. I'm going to do Unit 8, Progress Check, FRQ Part A, and try doing it with this live video and see how it goes. This is a calculator active question, so we'll be doing some cool stuff with that in a minute. And here we go. Gwen runs back and forth along a straight track during the time interval 0 to 45 seconds. Gwen's velocity in feet per second is modeled by that bad boy. Trig over a t plus 6. All right, so let's see. At what is the first time that Gwen changes direction? So we want to find Gwen's average velocity over the interval from 0 to that time. Okay, now remember, average velocity is going to be 1 over b minus a integral from a to b of velocity. So we'll be using that in a second. But if we want to find the first time that Gwen changes direction, we want to find the first time that v either changes from positive to negative or negative to positive. And we really don't know what this looks like, so we're going to plug this guy into the calculator. All right, so we're going to go to, whoa, that's some cool stuff, whatever I was doing there. So we're going to go to y1 and put in, I hope you can see that okay, I think so. Okay, we're going to put in 250 times the sine of quantity t squared, of course using x, over 120, and then divide that whole thing by the quantity of t, or x plus 6. Close it. Looks like we're going 0 to 45, so let me just do my window. Ooh, wow. Okay, well, let's just see. 0 to 45, and oh, let's try like 50. Let's see what happens here. Ooh, that's kind of pretty. Okay. We're going a little bit more here. We'll go like negative 25 to 25. See what that looks like. Oh, that's nice. Okay, so it looks to me, ooh, I wonder if we go to our table and look at the very beginning of this. Table set, start at 0, independent. Nope, let's do auto. Make our step size go by ones, just let's see. Let's see if, oh, come on. Yeah, auto, table. All right, well, let's just go back to the table. Let's go back to our tracing. Trace at 0 is 0, and then it seems to go up from there. Okay, cool. So it looks like the first time that it changes is right here. Velocity change from positive to negative right at that spot right there. So what we're going to do is we're going to use our calculator, of course, to find the intersection place. And sometimes I like to just give a little bit of an idea for them of, all right, velocity kind of looks like whoa. And it looks like we're looking for that place. So velocity changes from positive to negative right there, and that is at t equals, let's go find it. Oop. Second trace, intersect, nope, 0. Left, right, guess. 19.416-ish. Okay, so I'm going to put 19.416, and that's our first guy right there. What is the first time? And then we need the average velocity over that time interval. So we're going to go 1 over that value minus 0, integral from 0 to that value of the velocity equation. Now, since we've got our calculator, we're going to use it to our advantage here, certainly. And we're going to go, okay, that value right there, since that is the last thing that I put right there in my calculator, that's on the home screen as x. So I'm going to go x equals, and there's my value. So what I'm going to do is I'm going to call that, I'm going to store that as like a, okay? So now I can go 1, now I can go 1 divided by a times the integral math 9 from 0 to that same value of a. Now I need to do average value of the velocity, and since my velocity is going to be that bad boy, which we already had in y1, of course. So I'm going to go back to here, go back to where I was, and I'm going to put that into my y1, or I'm going to put y1 rather. Alpha trace y1 into there, dx, and my average value is now 7.2643-ish, and that would be my average value over the first 19.5-ish seconds. Okay, at time t equals 45, how far is Gwen from her position at time 0? Now we realize at time 45, now I'm just going to go to my picture here for a minute, my graph. Trace to 45. 45 is like way over here, right? At the end? Oh, of course it is. So she's going to, since velocity is positive, she's going forward. Velocity is negative, going backwards. We're on a straight track, back and forth, back and forth. So she's going forward, backward, forward, backward, forward, backward, a little bit. But it wants to know how far is she from her position at 0. We need to do a cumulative effect of adding and subtracting and adding and subtracting and adding. Well, what does that better than an integral? So the integral of velocity from 0 to 45 will do all of that for us. So that's all we've got to do. Now, we could, of course, do that in a really fun way. A reminder, second calc 7 from 0. It'll do the little shady shade thing for us. Come on, baby. Oh, it's thinking. There it is. Okay. Take that area away. Add that going right, take away that going left, add that going right, take away that going left, and we get this 116.538-ish. Okay, now that's interesting, because now, how far is Gwen from her position? She is 116.538-ish feet from where she was at time 0, from position at, I gotta make sure I'm writing neatly, at time 0. Find the total distance Gwen runs during the 45 seconds. Now this is great, because all we gotta do now is add all these together. Now, of course, we could have done, don't forget, we could have done this on the home screen, and I'm gonna go to the home screen, because on the home screen, I could have gone just math 9. Let's go from 0 to 45 of y1. And there it is, dx, and boom, boom, boom. And there's our pow, 116. Come on, baby. Come on, thinking. 116.538. But of course, what that did was that went add, subtract, add. But I want to add them all together. Well, if I want to find the total distance, I'm just going to find the integral of the absolute value, and it will add them all together. And that is very easily done on the home screen. So I'm going to go math 9. Let's go 0 to 45 of the math prob. Nope, just kidding. Math number absolute value of alpha dx. Hey-o! So now this should add them all together, and we're going to get lots more than 116. We're going to get, come on, baby. Okay, while it's thinking, I'm going to write down what I did. 0 to 45 of the absolute value of the velocity. And that equals, am I paused or am I thinking? Oh, my Lanta. Well, it's thinking. I wonder. That's interesting. All right, let me go to my picture instead. And let me do a graph of, I can't stick an absolute value and place it all in there, but maybe I can just go absolute value of y1. Oh, Lanta. All right, let's see. And I'm going to undo, deactivate number 1. So there's our boop, 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 boop. And now, maybe I'll just go second calc 7 from 0 to 45. It should be somewhere way bigger. Man, this is going to really have to think. Calc integral over interval. All right, I'm going to set that thinking for a second. And I don't know why it's taking so long. I don't know why it's taking so long. All right, so let's go to letter D. Let A represent Gwen's acceleration during time 0 to 45. Find the value of 15 to 30 of A using correct units. Oh, there we go. Hey! There we go. It's doing it, baby. It's doing it. Okay, 250.09947. Uh-oh, that's not exactly accurate. Oh dear. 250.099. Well, that's right to 3 decimal places. So we got 250.099. I'm gonna truncate there. Interesting level of accuracy there. So final total distance is that. Okay, now what I'd like to do is find the value from 15 to 30 of A. Well, of course, A is V prime. I'm like, uh-oh, I gotta find V prime. Well, interestingly enough, if I'm trying to find the integral of V prime, this is cool. The integral, you can see that okay? The integral of A from 15 to 30 is really just the integral from 15 to 30 of V prime. But we all know, according to the fundamental theorem of calculus, that the integral of V prime is just V from 15 to 30. And we can calculate that because we have the function. So now all I'm going to do now is use my calculator to help me out. And I'm going to go, what is y1? Oh, let's make sure. Good. What is y1 of 30 minus, what is y1 of 15? Oop, Nicky's. Okay, there we go. And this gives me negative 4.8442. So this is using correct units, feet per second, because we've got velocities. All right, so there is FRQA Unit 8, number 1. Hopefully you can see all that. There is the entire thing done. And there we go. Thank you, guys.